Well, many of you have been to an event of the VSF before, and you've heard that there is a ground-to-cloud, cloud-to-ground, ground-to-cloud-to-cloud-to-ground, GCCG working group, and boy, is there ever. What have we been doing? Well, we talked a lot at first about operating points. I'm going to go down to one of these. I'll go with this one. Wait, now it's there. Okay, 2 is 1 too many. So these operating points, how do you send content to the cloud? How do you get content back from the cloud? There's all the usual ways. You can use JPEG XS, you can use H.264, you can use HEVC. There's a whole lot of activity in the world going on about it. And so we decided pretty quickly as a working group that we didn't need to add a lot to that. We kind of identified typical behaviors. People either running in kind of a bandwidth optimized mode, or they're operating at like an intermediate mode for typical television contribution schemes, or for maybe the highest quality things, they'll run in, say, JPEG XS using maybe Tier 08 or something like that. And all 3 of these exist in the wild, and we said, that work is good and you should use it, and that's about where we left it. Then we thought about to create an ecosystem where vendors can build things and plug them together so customers can buy solutions. What are the points where things have to interoperate? So if you're sending a stream up to the cloud, it's very clear that you have to identify the standards involved kind of all the way down to the IP layer. So it's, a JPEG XS wrapped in RTP, wrapped in UDP on IP, sent to an address, maybe using, RIST or SRT or something as a protection protocol, but you have to identify the stack of standards all the way down to the ground. If you're building applications that are running in some kind of hosted computing environment, you probably don't want to try and specify the interaction of those things all the way down to the ground, because each of the cloud providers has a fairly different way of interconnecting things, and they have optimizations that are unique to their platform. So we established that what we really needed to do was work on an API, that big yellow line in the middle, that lets an application say, hey, I want to send this frame of video to somebody, drop it on the API, and know that it's going to get there without having to specify the specific implementation underneath that does it, because that could be different in different environments, likely will be. So the how do you get there, how do you get home? At the risk of calling it done, it's done, and we proceeded down the path of the work in progress of that API. Now, one thing we decided is inside a data center, as Andy alluded to, there's no reason to perpetuate this idea of synchronous frames. And if you tweak the color of something and then you're handing it to the next process, there's no reason to pad that out to a frame time, right? You could run fast. You could run ahead. You could work ahead. You could occasionally get behind. But there's no reason to go with this like big frame step pipeline like we've had for years. As I mentioned before, different operating environments might have different optimizations at transport layer, so we focused on having an API and having a timing model that allowed you to work ahead or be behind. So what's going on in all these organizations? Well, in the VSF, we've standardized the premium compressed use case. We thought about, is there anything more that needs to be documented for transport stream use cases? Mainly the RIST work, I think, is the big thing that's going on in VSF around that, and to some extent, Tier 09 also adds some, control layer values on top of that. Then we said, okay, this timing model, allowing things to proceed ahead, be behind, but work out to a fixed delay at the end. That was something new and different, and so the work of the group largely focused on that third bullet of how do you we've all done work with software-based workflows. And typical practice is, it's going to be a little sloppy on the timing, so you add some more buffering, hoping that at the end you'll get something smooth. And if you just add enough buffering, it always works. But if you're trying to do an integrated live television production, that buffering is a real operational annoyance. What you really want to do is add just the right amount of buffering to make it work, and not too much, so to have a bound on how much latency you're going to add. And that's the entirety of what we focused on, is how to manage that drift and catch up and the variability that could happen in a software-based workflow, so we can get back those frame delays of a fixed frame pipeline. In the end, these workflows can run faster than a typical, everything takes a frame time kind of methodology. So to avoid it, what did we do? We allow variability in the handoffs, but you have to say how much you're going to vary by. And we identified all these different use cases. There's some workflow steps that have 2 inputs, and they have to reconcile the timing of them. That doesn't mean they have to delay them or linearize them. It just means that they are a point in the process where 2 things have to both be available. We talked about the sources of variability, and we developed a vocabulary for how to describe the variability and latency of each step and how they propagate through a system. There's pictures and math, but it's not hard math, right? It's really pretty simple once you develop a vocabulary of how to talk about the amount of time something takes, how much variability it could take. Things basically can run as fast as they can, but they have to specify what's their 99.9% of the time they're done by time frame. And then those things stack up through the string of workflow. All to say, this work's been going on for longer than I'd like to admit. For the getting there and getting home, you could use TR08, TR09, H.264, H.265, lots of good ways. They're all basically linear codecs that at the point where they enter the cloud, they decode a linearized stream of picture, picture, picture. They could work ahead a little, but typically don't. And in the encoding process to leave the cloud, the codecs are typically expecting a sequence of very well-timed deliveries of picture, picture, picture. But in between those 2 things, you could have a variable timing model that floats and does whatever, as long as you recognize that at the end, it has to return to linear at some point. But that point gets further away. For the inside the cloud, handing things from workflow step to workflow step, we said, okay, we're going to document an API that applications can drop a frame and some audio maybe onto, and it shows up at the next workflow step. And how it gets between those things is up to the provider it's running in. We're going to use NMOS to describe those connectable items. And this API definition includes how are the pixels organized so that applications can drop it in. We have a default method that is basically the 2110p group schema, but we do have methodology where you could offer and ask some more complicated thing if you want. All that said, where are we? We have published a document. So if you go to the VSF website, which is vsf.tv, or probably as a longer version, you can find Video Services Forum Technical Recommendation number 11 of 2024. And there it is. And that's the output of our group. We're really happy it's out and done and published. Now, it's published as a draft. And this is a little bit of a process we've been doing on a couple of things in the VSF. But the draft is there. The draft is also or about to be copied onto GitHub in case you like to find things there. And there's a feature in GitHub called a discussion. And that's what we want to use for people to make comments on this document. It's there in public to be commented on. So by all means, use the discussion feature to start a thread, start a discussion. A discussion is a step short of an actual pull request or issue. You know, a discussion could result in an issue or a pull request or a change request, but it doesn't have to. It might be clarification, it might be, I wish section 3 said more about this, but the whole purpose of publishing it as a draft is to encourage and engender public discussion so we can cause the document to be more perfect in the future. And that said, are there any questions?